And we could do something similar with Arduino. In other words, turn something on and have it on for a period of time until something happens. Read switch here, read switch here. We are using a relay, but we don't need to have a latching relay, because when we turn it on, Arduino keeps the code because it's just acted on that single action, and then we can turn it off. It doesn't matter how long we hover here. Turn it on, and it stays on, and turn it off. Now, however, supposing we want to go in a different direction, we're not going, as in this case, left to right, but we want to turn it on going from right to left. My application in this case, where I want something to go from left to right and right to left, is for a diamond crossing or an X junction on a model railway. And now we'll have a quick look at the code for the Arduino. It's fairly simple. Okay, so what have we got here? We've got our Arduino circuit diagram and our coding. This is Arduino. This is our relay. These are read switch 1, read switch 2. These are pull down resistors. And this is our LED that we want to turn on and off. This is the coil of the relay. When this is activated, it switches the contacts from where they are now, which is common, through the 5 volts of the Arduino, normally closed, to common, normally open. As you can see, because it's connected to common, normally closed, there's no current flowing through the LED. Once the relay switches the contacts, it goes from common to common, normally open, and so it closes the circuit and we get power to the LED. So let's have a look at the code. You can see here we digital pin 2 is output, digital pin 3 is input, 4 is input also. So what happens? When read switch 1 is engaged or closes, that means digital pin 3 is now high. When digital pin 3 is high, 2 goes high. So what happens is we get 5 volts flowing through the coil, and it switches the contacts here from common to common, normally open, and so we get current flowing through the LED, and the coil stays active throughout that until we get read switch 2 engaged. If read switch 2 gets engaged, it means digital pin 4 is high, and then Arduino turns this low so the voltage goes off and the pins and the contacts switch back to the original condition and the LED goes off. Okay, so this is our diamond crossing. We'll show you without the trains in a minute. So you can see the main line crosses the down line goes across both tracks. We have our up line, suburban line here. So clearly we don't want them to crash, and that's why we want to control the junction. So the idea is that when our system detects the main line, the down line going through here, it stops part of both these lines, and it works in both directions, which is important. And then also then, if our system detects either the suburban or the down or the up line coming into the junction, it stops part of that. So it's what I call a first come, first served operation. Whichever loco reaches is detected coming into the junction, it cuts off part of the other two, and therefore we don't have crashes. Okay, here's our diamond or X crossing. We have our down line, our up line, and our suburban line. So clearly you can see if a train is in the down line and either the suburban or the up line approaches from either side, we're going to have a crash, and that's what we're trying to avoid. Okay, the principle of operation of this circuit is that we've read switch on one side of the diamond crossing, and another read switch on the other side of the diamond crossing. The idea is a loco passes over that read switch and power goes off to one of the tracks. And when the loco goes through the crossing, clears the junction, it'll pass over that reed switch and turn back power on. Also, the idea of this one with the software is that it works both ways, that I can sweep this way to there, if you like left to right, and right to left, and it turns off, on and off. So let's have a look. So again, turns it off, turns it back on again. Again, need to have quite deft sleight of hand. Come in the other direction, turns it off. You see, it wasn't quick enough. Still not quick enough. And turns it back on again. Again, you need to sweep over that quickly and get the magnet away so it doesn't double click again. And that's kind of our problem with reed switches. Okay, we have similar circuit diagram as before. We've our Arduino, our reed switches, and our relay. Now, our code is much different this time. We're setting up a Boolean operator called junction clear. We can see our pins are very the same. But what junction clear does is, it's Boolean, so we set it up as junction clear equals to true. So when junction clear is equal to true, nothing happens at the relay. Okay, and we set the relay low at the start as well too. So what happens? If reed switch 1 or 2, in other words pin 3 or 4, go high, it changes junction clear to not junction clear. If we have a not junction clear, the else comes into play, and digital pin 2 goes high, relay contacts change, and in our case the LED goes off. So the problem we're having is that, and it works both ways, either direction. So what we want to happen is reed switch 1 goes high, relay activates, then reed switch 4 goes high, relay deactivates to simulate a loco going through the junction and exiting the junction. Goes through the junction, starts reed switch 1, exit the junction, reed switch 2. Now the problem is that reed switches tend to double read sometimes. They make several contacts in the same sweep of the magnet. So what's happening is this here, junction clear, is flip-flopping between junction clear not and junction clear yes, or true if you like. Now I've been playing around with the delay function here to try and capture one click, if you like, of the reed switch with not much success so far. And we'll see that in follow-up videos showing you some of the hardware problems and then the problem with the delay. And there's a kind of a sweet spot, but bottom line, I've moved to another way of doing it,